ancient history, creating software involved a lot of manual labor. We would invoke compilers by hand, perhaps manually run tar on a bunch of compilation products to package. More sophisticated engineers would handwire dependencies in a makefile, but even that is lots of work. This is a representation of the work that happens. So eventually we came up with the IDE, the Integrated Development Environment, which offers an interface for the whole software development lifecycle, from editing, formatting, refactoring, to a structure for organizing your code into projects and modules, compilation units, and on those you would do running, testing, debugging, packaging, deploying, all at the click of a button. Now, I think buttons and UIs are great. That's why I work on one of them on IntelliJ, on the Scala plugin. For IntelliJ, I'm Justin Kaeser. As you can see here, that's my name. I am also on Twitter, Ebenwert, and our team is also on Twitter as IntelliJ Scala. Just quick show of hands, who uses our fine product? Wow, thank you for your continued support and paying, hopefully, to let me come to these conferences. By the way, who knows we're on GitHub? Like, our source code is open source, mostly. Just a few. Oh, well, now everybody of you knows this, okay? Remember. So if you're very unhappy with our code and think we're not working right, you can do the work. Yeah. So, but the purpose of this talk is to talk more about the integration part of the integrated development environment, namely to a way to integrate build tools more seamlessly. As the title says, build server protocol and beyond. It's mostly about the build server protocol. And I'll just give you the approach we took in enabling this integration and some specifics about the implementation of BSP. So I mentioned the old way of doing things manually from the command line. It turns out that's still kind of useful, even with a nice development environment in front of you, because using specific tools for specific jobs allows you to combine these tools. You know, the Unix philosophy. One job, one tool, do it reasonably well. And this is also because, like, one size does not really fit all in development. So having one tool for all the jobs, as in the IDE, well, you're probably unhappy with at least some of the aspects. Like how do you package things, or how do you define your project? How do you share your project with others? On the other hand, I really would like a unified environment to work with all the tools I otherwise use in the CI environment, for instance. The cross-platform tools. So traditionally, yeah, we've taken the approach of integrating tools one by one manually into the IDE. And as you can see here, this causes a bit of a mismatch in styles. Like, it doesn't quite fit together. there's idiosyncratic configuration and APIs, and each tool needs a specific way of integrating it. And as I've listed here just a few of the integrations we've done with IntelliJ, like specifically for Scala test specs, JUnit, for SBT, for various frameworks such as Akka, Play, Scala FMT. And we're not the only ones who have this problem. So Bloop, which John mentioned and which Jorge will talk about later today. By the way, we switched talks in case you haven't noticed yet. Bloop as well needs to integrate with a number of build tools. So, since we're in England, a bit of an English classic literature quote. It is a truth universally acknowledged that any Scala developer of a certain seniority will be in want of his own build tool. Jane Austen. So, yeah, we have lots of choices in build tools. John just talked about his way of increasing the choices. And there's little coherence as to how they work or how they work together, how they work with an IDE. And I'm still wanting to use my own IDE that I work on, preferably. And instead of, context switching between terminal and IDE and web interface or whatever. So that's a bunch of manual steps that could be all a bit more seamless. So yeah, we have this tangle of tools here, right? It's a mess. You don't know which hand belongs where you put your hand. And so our haphazard integrations sort of keep these tools together, but it's not entirely coherent. So I've been trying to tie up some of these loose threads to create a more integrated developer experience. But first, some prior art. You might have heard of the language server protocol. Just quick demographics here. Yeah, a few of you. It's a protocol developed by Microsoft for the Visual Studio Code editor originally. And yeah, it addresses this one major integration bottleneck, connecting a compiler to the editor. So far in IDEs, including IntelliJ, we've mostly done this by writing language-specific support into the IDE. Now, that doesn't scale all that well if... So, yeah, they developed this protocol that defines some standard actions that you can take on code and getting feedback from the compiler, so-called diagnostics that are basically just error messages, warnings about some problem or some information to get feedback in specific code points. So this protocol has been so successful that people keep asking us if we're going to use it for Scala 3. And in previous incarnations of this talk, I said probably not for various reasons, but actually last week we were just experimenting with this and it kind of seems to work. So we'll have at least an easier way of giving basic support for Scala 3 and maybe even Scala 2 via the language server protocol. But that does come with various challenges and trade-offs or drawbacks. So LSP as such doesn't really model the structure of the code base, which we use for many of our features. Such as, navigation, dependency resolution, and so on. So all you get is a simple message here's a problem. And the structure of the code base and the structure of the code itself is what we use for various other features besides navigation, like refactorings. And so there's no common concept of building, testing, running code in LSP. So we still need to know the structure of the code base for that, or we need a way to tell the language server or build server that these are actions we want to do. Now, build tools. There have been a number of tools emerging, such as John's Fury just now, well, for the past year or so. From Desert Sands and other places. So Mill is another tool developed by Li Hao Yi. Before that there was CBT. More recently, I think there's a small tool called Seed, which just cobbles together a few ingredients to create a new build tool out of Bloop and Corsier and so on. So there's a variety of choices. Most of these tools don't have a significant user base, so it's hard for me to justify spending a lot of time on supporting them specifically. And likewise, if I ask a build tool author, hey, are you going to support IntelliJ? And they're like, meh, I use VS Code, I use Vim. So we've got a bit of a chicken and egg problem there. But I still would like to open the Fury projects in IntelliJ and not in Vim, because I can't remember how to exit or even enter. So let me just show you something. This is a high-resolution screen. Presentation mode. Okay, that doesn't show you everything you want to see. But here you get the idea. This is just an overview. This is Fury. I opened it in IntelliJ just like that. And you may or may not be able to read the individual bits of code, but like other basic features such as navigation to definition and so on, they work. So how did I do that? John mentioned it earlier. I contributed the build server protocol support to Fury. Now usually I wouldn't do that for a tool that has no users, but I figured it would be a good way to kickstart the adoption of the protocol. And so instead of implementing support for individual build tools, there's this quote from maybe Abraham Lincoln, or maybe it's made up, but it was something like, give me 6 hours to fell a tree and I will spend 4 sharpening the axe. I thought, yeah, give me 1 month to support a build tool, I will spend the first year developing a protocol. So we have a protocol now. That's kind of cool. So this might be the place to insert some XKCD comic. Anyway, Fury, John mentioned it is a BSP server, but it's also a BSP client towards Bloop, the compile server. So that's an interesting way of using the build server protocol to connect various tools. Now, what is this build server protocol? Conceptually, it's extends, or rather complements, the language server protocol. So it's based on the same base protocol, which is JSON RPC. And so, which means you have a bunch of requests and responses, and there's a concept of notifications. So this protocol was initiated and developed originally by the Scala Center by Jorge and Olaf. Jorge will be giving his talk later. And with contributions by myself, by JetBrains. So there's a bunch of generic concepts that it abstracts for various from various build tools. They don't map perfectly to each build tool, but well enough that we can define a common language. So most build tools have a kind of a project model. So in SPT we call it projects. In Maven, I don't know, I haven't used Maven in a while. In IntelliJ we have modules. In Fury we have modules. And in Bazel we have targets. So in BSP we call this targets, modeled after Bazel. And we have a bunch of operations defined as requests with specific semantics. I said it's a client-server protocol, but really it's kind of bidirectional, so both the client and the server may send requests to each other and await their responses. But more typically, the client sends the bulk of the request, and the server will send notifications, which are just one-off messages that don't expect a response. Now, we want to find a way to connect arbitrary clients with arbitrary servers. So in LSP, we don't have a concept for this, so a client implementation still needs a server-specific implementation to start a language server. In BSP, I thought this isn't quite good enough. I don't want to implement a tool-specific protocol, a tool-specific implementation at all, ideally. So we came up with this server discovery protocol. It's quite simple. When you install a server or when you download a build tool or a project which is connected with a build tool, you do a simple installation step, and the build tool will place a connection file either in your project directory or into some system predefined location on your system or user directory. So the client will then just pick this up, and in this connection file there's a few commands, like where is the build tool located, how do you start it, with what command line, and the client just does this, and it starts a build tool, a build server, which simply communicates by standard in, standard out. Now we have a bunch of lifecycle requests. So the build server needs to be initialized. It tells the client, hey, I'm initialized. Then the interesting stuff happens, and eventually the client will tell the server, please shut down. And once you're shut down, please exit. Kill this process orderly. Now I mentioned we have a concept of build targets. So the protocol defines some requests namely workspace build targets, which gives you a list of targets. You see a target is a compilation unit which encompasses a bunch of sources and maybe some metadata like capabilities. Can you test this? Can you run this? Can you compile this? And some language-specific data such as Scala SDK to use, or and a bunch of dependencies. So one target can depend on a bunch of other targets. So that's these hexagons and arrows here. And each target may be associated with a number of sources. That's the folders right here. Targets may share sources, or sources may be part of multiple targets. Oops, where are we? Here. Now you want to do a few actions. You want to interact with your build. For that, we have a bunch of requests, namely compile, test, run. A server might not have to implement all of them, but usually it's a good idea to at least implement compile. And so between requesting a compile and a response, the compile result, there might be a bunch of notifications from the server to the client. That's the diagnostics and progress notifications. I'll show you how that looks in a minute. Diagnostics are simply errors, warnings, information about certain code points in your code, or they might not be associated with a code point at all. They're simply, hey, your project has a wrong Java version, can't be compiled, or something like that. They're exactly analogous to the diagnostics in LSP, if you're familiar with those. Tasks are a way of communicating about longer running processes. So these are also notifications, usually sent from the server to the client. Like I started compilation of target A, and then there can be a bunch of task progress notifications. So I'm done 10%, 20%, 96%, or I have compiled 356 of 2,000 files, something like that. Likewise, they can give updates on tests that are running. These are usually associated with a request, but they might as well be sent at any point. So, like if the server wants to tell you, hey, I'm indexing stuff. Now I want to be more practical and talk about how IntelliJ acts as a BSP client. I'll show you another project for this. Where is it? This is, wow. Should have used a different resolution. Maybe it can do that quickly. This place. There, that's better. And it jumped to the other window, okay. So for instance, here is Akka. It's usually an SBT project, but Bloop offers a way to export SBT project definitions to a Bloop definition. Loop implements the build server protocol, which allows me to import the project into IntelliJ as a BSP project. And I'll run a compile, and it shows up in the build tool window. So right now you're not going to see much yet, except IDE error. Okay, yeah, sure. Okay, here you see just some log. Apparently something is broken right now. It's a good time for things to break. Okay, well, sorry about that. I've got backup plans. How about Mill? I had an intern recently, and she just went ahead and implemented the build server protocol for Mill. We have an open pull request for that. And this is the Mill build tool imported into IntelliJ via BSP. And I should be able to do a compile right here. And because the build compile takes a while, you'll only see some log output for a while until it starts actually compiling the modules. So I'm gonna have a look back later. So the build server protocol is now in the 2.19.2 release, which is the new one, supported as an official feature of the Scala plugin. We have the BSP protocol version 2.0 supported in IntelliJ, in Bloop, in Mill, in Fury. And so currently the support only really works well for Scala targets. Oh, come on. I'll just escape and play again. Oh yeah, here. You see. Oh, sure. Here, now you can see a bit of what's happening. So you see this target is being currently compiled. It's taking 55 seconds already. So you get updates on individual targets, so you can see a bit about where your compilation time is actually going. I think that's an improvement over what we have in most tooling integrations right now. And you see this whole bunch of warnings. They are usually, this one isn't, these are just generic warnings, but you have warnings associated with a given file, so you can just navigate over to them. In principle, we could use these warnings to also inform the highlighting in the editor. So that would be another way of avoiding the red code issues in projects that are prone to that. And actually, I intend to look into that for maybe the next release or the release next year as an option to, as an alternative to the built-in highlighting in IntelliJ. Okay. Yeah, I've just shown you how a compile request looks. One step back. So what actually happens when we import a project into IntelliJ? So various build tools have different ways of representing their builds. Here I'm going to look at SBT, for instance. So SBT has the concept of projects, which are the compilation units. But these projects are kind of subdivided into scopes. Most people just use a compile scope and a test scope. Likewise, On the IntelliJ end, we also have compile and test scopes in an IntelliJ module. So that maps more or less straightforwardly. One issue we have in BSP, we simplified this a little. We just have targets without scopes. So mapping to BSP, when you do, for instance, a bloop export from SPT to bloop, it will map a test scope to one target and the compile scope to another target and put dependencies between these. In SPT as well as BSP, we can have sources shared between different projects or targets. In IntelliJ, unfortunately, we don't. We bind one IntelliJ module to a set of sources specifically. This has reasons because this informs the editor highlighting and we don't want ambiguity there. Unfortunately, this means we can't often can't directly map build tool projects to IntelliJ projects. So what we do here is we create a synthetic module that is associated with the shared sources and then put dependencies from the different modules onto these shared sources. That's the box you see in the middle here. That kind of works, but it will usually break compilation when you compile from within IntelliJ. Luckily with BSP now we have a bit of a way around this. We just outsource the compilation to the build tool directly. There may be ways of working around this, for instance, by keeping a model in the background that you can then switch contexts. So, for instance, shared sources are typically used if you cross-compile between different platforms or different Scala versions. So you could have a context for Scala.js and a context for JVM. Now a quick overview over the BSP ecosystem as it is as of today. We have as clients IntelliJ and Metals. So they all can use, in principle, any BSP server to integrate with. Fury is both a client relative to Bloop, so it outsources all its compilation to Bloop, and it's a server relative to IntelliJ or Metals. Then we have a whole bunch of build tools, SPT, Maven, Gradle, Pants, Mill. They aren't, as of this moment, BSP servers, except for Mill, but they have an integration with Bloop. So you can export their build definition to Bloop and then use these projects in IntelliJ or in Metals. And that already enables us a way to integrate with many build tools, even if they don't have tool-specific, client-specific support, or the client don't have tool-specific support. Yeah, I put Mill here a little outside because there's the open pull request. And you can, in principle, already use it. Now that's the state of the BSP. I want to give a short roadmap. So, yeah, the protocol version 2.0 is basically done, so all the tools currently implement this version. We might have some minor tweaks yet to work out. IntelliJ, Bloop, Fury, Mill all work with this version. we are looking into supporting more build tools, of course SBT, because the current integration of SBT in IntelliJ, which I have been working on, is not up to it doesn't work the way I'd like to. Other tools, especially like multi-language tools such as Bazel, would be very interesting to integrate with, especially if these tools like support remote building. And likewise, if we have tools in different languages supported, we need to support these in IntelliJ and improve how we map the project so it's generally easier to work with. Test requests, I had another intern who actually implemented this just the past month, and you can now run tests over BSP from IntelliJ. This is helpful if you have a test tool implementation in your build tool, but not in IntelliJ or in whatever front end you prefer to use. Now going beyond the build server protocol, if this works out well, it might be a model for further tool integrations in a more standard way rather than ad hoc tool specific. So several people have asked me about doing static analysis on source code and integrating that with the IDE. Typically that's also done with IDE specific plugins, or you just go to a web front end, or you use a command line tool. Ideally, I'd like to just press a button in the IDE and it gives me the list of problems, just like it gives me the compiler warnings. So that would be an interesting point of extension of the build server protocol, or of another protocol maybe. Testing, we have testing support in BSP, but maybe we'd like it more fine-grained, so like a standard way of addressing specific tests. That's a thing that doesn't even work that well in SBT as soon as you use multiple test frameworks, because it's framework specific. Remote building would be really great if you work on a weak MacBook or other weak notebook and have huge projects that you compile. So making that interaction more fluent. Of course, there's certain challenges here. Yeah, KCD comic, you have 14 competing standards. You decide you want to make another standard. Now you have 15 competing standards. That's competition, but likewise adoption. To make such a standard useful, you want to have people adopt it. And that's why I'm here speaking to you to, raise awareness, hopefully reach people that want to work on build tools or are working on tooling at their company. So in fact, BSP is already being used internally in some places to integrate with IntelliJ. And that could be a model for your organization. Yeah, so this is just for your inspiration. I'll upload the slides. There's a few links. So if you want to look deeper into this, there's the BSP specification and libraries on GitHub. And I've recently turned this talk into a blog post that's on our IntelliJ plugin, Scala plugin blog. Since John asked for people to give workshops, I'll be giving a workshop on BSP. So the idea is we'll create a build tool from scratch because, everyone needs their own. And all the ingredients are really there. We have Loop for compilation, Kaeser for dependency resolution, BSP for communication with front end, and the rest is just a bit of library code, right? So it's going to be an experiment. Can we define a build tool that compiles a bunch of sources from scratch? Okay then, this is the end of my presentation, and I hope you have some comments or questions. Does anybody? If you don't, that's all right too. Okay. Thank you.